Hey folks, this is Mr. Bullock. I am Mrmathblog. If you like these videos, would you click like for me and maybe subscribe? If not, if you have some time, don't worry about it if you don't, no biggie. This one is this calculus lesson. It's a BC lesson. Is on trig integration and powers of trigs. Just more tricks on integrating, you guys. So let's go back and take care of number 22 on the last assignment right here. So the integral of that mess right there. So I did this, you guys. I let you, well, first I let you be the algebra stuff right here, this algebra stuff. And so what I happened, that just ran me into a dead end. So I tried this. I let you be the x squared, e to the x squared, the numerator part. And then so dv is the rest of that. Notice it's x cubed here, so there's one more x, so x over that right there. And so if I integrate that and do a little u substitution right there, I get v equal to negative 1 over 2 quantity x squared plus 1. Okay, and over here, I'd use the product rule right there and then integrate by parts. So here we go. Going to plug in uv minus the integral of v du. Okay, so you get all of that right there when you take care of that. All right, and then I GCF'd out the 2x e to the x squared right there. And then notice the 2's are going to cancel here, and the 1 plus x squared is the same as x squared plus 1. Those are going to cancel also. Okay, and then do another little u substitution over here. Okay, and I get 1/2 e to the u. And then so there's my final answer right there. Okay, so that's how I did 22. And so a lot of these times, you guys, I run into dead ends. I just don't snap them out right away, and you got to back out and try another way. So you'll see a lot of this. The heavier we get into this stuff, you just run into dead ends. Okay, recall back in pre-calculus the trig identities right here. Okay, and these are our half angle identities. We're going to be using all of these quite a bit. We're going to be using the secant squared and the tangent squared identities also. I should have wrote those down. I didn't, but they pop up in the lesson. You'll see. Okay. So what we're going to do is if we have the integral of sine to some power of x or cosine to some power of x or a mixture of the two, if they're odd powers, then you're in pretty good shape. You just use your trig identities. But if they're even powers, then we got to do the half angle identities. They're a little bit more challenging, and if there's at least one odd power, then you can peel off one, and then you'll see the tricks right here. So evaluate each. Okay, so here's an odd power. So I'm going to peel off a sine to the x, sine squared of x, and then what I'm going to do is use my trig identity, 1 minus cosine squared of x, and now I can do a little u substitution right there. And so when I do a little u substitution, it cleans it right up right there. So then there you go. There's my answer right there. Okay, nice and easy. All right, let's try another one. Okay, so if there's at least one odd power, then you can peel off one of them. So here, for example, here I got sine to the 5th of x, cosine to the 4th of x. So I'm going to peel off a sine of x right there, and then I'm going to use my trig identities right here. Okay, so this is sine squared squared, so here's my sine squared squared right there. You guys see what I did right there? Okay, and then I'm going to distribute, now I have it all in cosines, I'm going to distribute the cosine through right here. So here I go, and I get that. Oh, I guess I expanded it first. I'm sorry, I can't distribute it yet because that's being squared. My bad. Okay, and then now I can go ahead and distribute that guy through. Okay, and then so now I'm going to go ahead and do a u substitution. Whoops, sorry. You can see I just distributed it through, and then I took that bottom layer back up there. Okay, and then do a u substitution, and then I get that right there, and then so now it's just baby steps by now. Okay, so you get there's my final answer right there. Okay. All right, so let's try another one. So evens aren't as nice, although they're not too bad, you guys. Okay, this one's even, so I got to do a half angle identity with cosine squared. So there that is right there. Okay, and then pull out the 1/2. Okay, and then so I go ahead. Remember when you integral cosine, it's sine, but you divide by the chain. So I divide by 2, so it's going to give me a 4 down there. Okay, so that's the answer right there. Okay, and then this one right here, okay, I'd use my half angle identities for both of those right there, and then I foiled those guys out and pulled out the 2 and 2, which is 4. Okay, and then what I did right there is this is sine squared right here, but this is sine squared of 2x. So I used my half angle identities, except it's 2x right there. So what I'm going to do is make it 4x right there, but and the 1/2 is going to make this there's my 1/2 right there. So I use my half angle identity again right there, half of 4 is that 2 right there. So there's my half angle identity. Okay, and then let's see, so that 2 came out with that 4 and made it 1/8 right there, and then go ahead and distribute through, I'm sorry, yeah, distribute the integral through, and then you get that as your final answer. All right, okay, now I could have done this, you guys. I could have recognized, since sine of 2x equals 2 sine x cosine of x, I could have divided both sides by 2 right here and got 1/2 sine of x, 1/2 sine of 2x equals sine x cosine x. Okay, and then since I have sine squared cosine squared, then if I square this side, then this is going to change this to a 1/4, so I can make this 1/4 the sine squared of 2x right there, and then we get back to this step right here. Okay, and you get the same answer right there. So you could have done it that way also to get the same answer. Okay, so now is secant tangent, you guys. So when you have the integral of tangent to a power, secant to a power, then use either u equals the secant of x, and then du would be secant tangent, or do u equals tangent and then du would be the secant squared. Okay, so it just depends. And if both of those fail, then you're going to integrate by parts, and sometimes that gets pretty messy, and I have some examples. So evaluate each. Okay, here what I'm going to do is if I did tan cube of x, secant of x, it doesn't work. I ran into a jam on that one, so I tried pulling out a secant x tan x. When I pull a secant x tan x out, remember the derivative of secant x is secant x tan x right there. So here's a substitution right there for tan squared of x right there. Okay, so that's what I did, is I pulled a secant x tan x out right there. Okay, and then I did my Pythagorean identity right there on that. So tan squared of x is secant squared of x minus 1 right there. Okay, now I'm going to distribute the secant squared through, and I got it all in terms of secants right there, and then now I do a u substitution. Remember, if u equals secant of x, then du would be secant tangent x. So there we go. Okay, so it gets me that. I did u equals secant x, so du equals secant tangent x. So here's u to the 4th, here's u squared, and here's du right there. Okay, and then there's your answer right there, nice and easy. Okay, all right, let's try this one right here. Okay, so there's ways to do this. If we take out secant x tan x, then you get secant cube x tan x, and I ran into a jam on that one right there. Okay, so what I did is I pulled out the secant squared x right there, and then I did another identity right there. The identity was this dude right there, and then I did it all in terms of tangent, and distribute the tangent through, do a little u substitution. So u is tangent x, so du is secant squared x, so there's du right there. There's the final answer right there. Okay, so just some planning here. Okay, on this one right here, if I took out secant x tan x, then I'm left with tan squared secant cubed. Okay, tan squared is secant squared minus 1. Okay, and if I took out the secant squared, then I'm left with tan cubed secant squared, which is this right here. So I chose this path right here, the first path right there. So there it is right there. Okay, so and then now I can go ahead and distribute it through right here. So this becomes I did secant x times tan x squared secant squared, and I substitute that in, and I distributed that through right there. Sorry, I shouldn't have done it all at once. So that's what this is right here. Okay, when I distributed this through right here. Okay, and then now I can do a u substitution on that, and then it kind of falls apart after that. Okay, so there it is right there. Okay, and if you're given secant cube of x, then you can't do the power tricks on this one. You just kind of run into a jam both ways. So you got to integrate this by parts. So let u be the secant of x, and then dv is all the other stuff, and then just integrate that guy by parts right there. And if you have tangent cube of x, then I would separate it to tan x tan squared of x. Okay, and tan squared of x is secant squared of x minus 1. Then you can separate those up, you guys. I distributed this tan x through right here, so tan x goes right here, so that gets me these two integrals right here, and then you're off to the racetracks. That's this is u, this is du right there, and the integral of tan x is the natural log of absolute value of cosine of x. Okay, that went a little faster than I thought, a little bit easier. If you're in my class, I would assign that one for your homework. Take care, you guys.